established with ground team. Roger. Receiving real-time updates. Moving to phase line 2.
Multiple security layers protect the facility where F-35 stealth fighters are built, safeguarding advanced aerospace.
Strict security checks ensure only authorized engineers and technicians enter the classified production zones where the F-35 stealth fighter is manufactured.
Inside the factory, secure corridors connect specialized departments where engineers design, assemble, and engineers monitor every stage of F-35 production here, ensuring each component moves precisely through the complex manufacturing process.
Inside this massive assembly hangar, technicians integrate thousands of components to form the advanced structure of the F-35 stealth fighter.
Precision robotics help engineers assemble complex aircraft structures with extreme accuracy required for modern stealth fighter production.
Massive aircraft sections move carefully between assembly stations, preparing the F-35 for the next stage of construction. Engineering teams analyze data continuously to ensure every F-35 aircraft meets strict aerospace performance and safety standards. From raw materials to advanced combat aircraft, the F-35 production line transforms engineering. The F-35 begins as a digital design. Engineers shape its stealth geometry and aerodynamics using advanced simulation technologies.
The simulation confirms the design adjustments. We have achieved near total deflection in the C-band.
Engineers simulate radar signals interacting with the aircraft to measure and reduce the F-35's radar signature.
Wind tunnel experiments help engineers refine airflow, stability, and aerodynamic performance for the F-35 fighter.
Lightweight composite materials strengthen the aircraft while maintaining stealth performance and structural durability.
Radar-absorbing coatings help the F-35 remain nearly invisible to enemy radar systems.
We have a rapid pressure drop at 30,000 feet.
Compensating. Rerouting hydraulics now.
Internal temps are stabilizing. Good recovery.
The F-35's avionics system integrates radar, sensors, and communications into one advanced digital combat platform.
The F-35 cockpit integrates advanced displays and helmet technology to give pilots unmatched situational awareness.
After years of research and simulation, the final aircraft design is approved for full-scale manufacturing.
Fiber orientation looks perfect here. Confirmed. The vacuum seal is holding steady. We are good to proceed. The alignment on that last panel was flawless.
Yes, the calibration held steady throughout the cycle.
Ensure the orientation matches the grid line exactly. Copy that.
The laser alignment looks good on section 3.
The readout is showing optimal vacuum. Confirmed. We are ready for the next stage.
The surface finish on panel 4 looks perfect.
Confirmed. Ready for the robotic transfer.
Check the alignment on panel 4. The specifications are holding.
Laser verification is solid. The trim is perfect. The trimming operation on this section is complete. Verify the edge profile against the specs.
Looks perfect. The integration should be seamless.
The structural integrity checks out on the main spar.
Good. Let's authorize the lift sequence for Bay 3. Check the alignment on Sector 4 Bravo. The laser guide is showing a 2mm drift.
Copy that. Adjusting the platform now.
We're showing perfect alignment on the forward section. Copy that.
The monitors confirm stability across all metrics.
Ensure the alignment matches the specs on the tablet.
Looks good from here. Bring the crane down slowly.
The forward spar connection looks good. Are we clear for fuselage integration?
Yes, the automated drill sequence completed without any anomalies.
Alignment check on the port side.
Green grid is locked, tolerance verified.
Proceed with fastening sequence.
Check the tolerance on the forward mount. It looks slightly off on the schematic.
I see it. Adjusting the hydraulics now to compensate. Alignment data on the fuselage looks good.
Yes, the scan confirms dimensional accuracy across all points. We are clear for the next phase.
We need to verify the alignment specs on screen 3.
Okay, I'll cross-reference the hydraulic schematic before they move it.
The surface finish is exceeding specifications on this batch.
Agreed. The parameters look stable.
Monitor the temperature during the pour. Keep it steady at 1600.
Copy that. Flow rate is optimized. Make sure the alignment is verified. All right, team, let's initiate the slow rotation for inspection.
The bore scope shows a clean seal on injector 4. Copy that.
Proceeding with the final torque sequence.
Alignment confirmed. Proceed slowly to setting depth.
We need to verify the alignment of the structural frame here.
The diagram confirms the interface requirements.
Okay, initiate the final torque sequence on those main bolts.
All right, team, easy now. Bring it 5 centimeters to the left. Watch the clearance on frame 7. Lower the main assembly, slow and steady. Watch the starboard coupling.
Copy that, lowering now.
Alignment looks good on this side. Keep it coming down.
Connection secure on mount point 7.
Confirmed. Diagnostics are showing green across the board.
This sensor array needs recalibration before integration.
I agree, the telemetry is fluctuating outside parameters.
Alignment confirmed. Securing mounting points.
Diagnostics complete. Radar calibration successful.
All pathways nominal. Integration complete.
Confirmed. System fusion is successful.
Alignment is complete on the DAAS array.
Running final diagnostics. Looks good. Spherical coverage is nominal.
Diagnostics are nominal on bus 3.
Confirmation tone received. We have a green light across the array.
The frequency response looks stable across the band.
Confirmed. The integration is holding nominal parameters.
Boot sequence initiated. All systems nominal.
We have a solid radar lock on the simulated target. Track stabilized.
All systems are green across the board. Look at the data stream from the central processor.
Signal integrity is holding steady. We are cleared for integration.
Apply the stealth coating evenly, maintain the aerodynamic surface.
The smoothing tool is set for the required thickness.
We have green across the board on the laser scan.
The temperature in zone 3 is showing minor fluctuations.
Adjusting the airflow now. Levels stabilizing.
The surface analysis shows 0 microscopic imperfections on this section.
Confirmed. The stealth coating thickness is optimal.
Reviewing the final specs now, everything aligns with the schematics.
Confirmed. The signature levels are nominal across the board.
All systems are green across the board. Look at the data stream from the central processor.
Signal integrity is holding steady. We are cleared for integration.
All green on the hydraulics bypass. Confirmed. Avionics check is nominal across the board.
Final systems report uploaded. We are go for operational testing.
Sensor array alignment is holding steady across the board.
Confirmed. All systems are within operational parameters.
The pressure on the starboard aileron is fluctuating slightly at maximum deflection.
Noted. Response time is still well within the green boundary.
Sign off confirmed on the nose cone.
Good. The radar alignment looks nominal.